I'm Joanna Simpson here at RiskWines International in London. Joining me now is Alexander Sokol, Executive Chairman and Head of Quant Research CompatibL. Thank you very much for joining me today.
Thank you.
And you're organising the hackathon at QuantMinds International for the second year in a row. What changes have you noticed since last time?
I think there's a tremendous change in how people approach AI and how they put it to practical use in the banking industry. So last year, it was more like, when TradeGPT first came out, people say, well, come up with a poem, right? So last year also, a lot of it was around the chat. So during the hackathon, we've been working on a prompt to make sure that the model can recognize, the trade. And this whole thing was, we're asking for the data, but we're asking in chat form. So this is something for assessing the ability of LLMs to do it, but was not really in any practical form that can use in the bank. So the change this year was that we had an open source package, and we have a growing community around this package called TradeEntry. It says TradeEntry.ai. All of the information about this package is online. And people have been very comfortable using the package, how the participants were coding, in submitting the solutions through GitHub. Half the participants were using our online playground at Playground TradeEntry.ai. And in both cases, this is something that the solution that people came up with is something that can be put to use as soon as it can be integrated. In other words, it was not a gimmick, it was not a toy, right? This was actually a real thing that you can go back to your desk and put to real use.
What were some of the most innovative or promising projects this year?
Okay. So, well, we're still scoring. We'll be very soon announcing the winners. And so far, with the wealth of very, tremendous work I think done along many different directions by participants. So, for example, some of the participants were looking at using one model as a challenger for another model, which is a very innovative approach we didn't think of before, and we're actually thinking in an open source project also incorporating this capability. Others were improving the quality of the prompts, where we're giving more context or more nuance about how to interpret, how to essentially bring our knowledge as a community to the open source software, so it knows all of the rules and knows everything. And I think that what I was especially impressed with is that the approach that I was presenting at the conference, in which also was published and discussed as part of this open source initiative, where you don't ask the LLM to give you the entire answer at once. You don't just say, here's the trade, tell me, or here's a trade and here's a 500-page book of, what the trades could be, tell me, right? But the step-by-step approach where you do, very small bite-size questions, so you gradually move toward the solution, almost like, if you're a senior trader and you're explaining to a trainee, let's do one step at a time. Like first, like you determine, what kind of a trade it is, right? And then you determine, is there any particular aspect to this trade in a specific currency that's different from the common convention. So I was very impressed that participants were able to use this kind of a very nuanced and step-by-step approach, almost like a mentor explaining to someone, to a junior colleague, how to do it and put it to use in actual code or in this playground application and configure it to provide much better results than were possible before. And all of the results we're getting, they're like 90+% accuracy, despite very short time spent on doing this during the hackathon, only a few hours. So I think that if the same group was able to work with it as a proper software project for a week, the accuracy would be like 99+%, which is exactly where we want to be, right? So we want the accuracy of this AI-based approach to be similar to accuracy of humans, right? Humans make mistakes, AI makes mistakes, right? So our goal is not to be 100% accurate. That's not possible, right? We want to be as accurate as humans.
Using LLMs for trade entry and capital markets is an innovative approach. What inspired CompatibL to focus on this particular application of AI, and what opportunities do you see in this area that may have been overlooked?
Yeah, I think there's a tremendous value that can be unlocked by using AI, LLMs in finance along one particular aspect that actually has been kind of the focus of attention in the financial industry since I started in 1996, right? And the problem is still not solved. And this is dealing with tremendous wealth of data that the bank has, which is really in natural language format. I do not want to call them documents, because this is really the data in unformatted, form, right? So it lacks a proper representation in a database, but it's still data nevertheless. For example, term sheets, right? So a term sheet is data about the trade that tells the bank when to send the payment, what the amount of this payment in a financial transaction. So this is data, having incorrect interpretation of this data can have very severe operational consequences, and yet is stored in a document which is a 300-page, 100-page term sheet or description, which really lacks any firm, rigid format. ISDA has done a great job providing this templates. So particular styles of these documents, have kind of established sections that should be there, established formats. Nevertheless, it's still a document. But for other transactions, it's much less standardized. People are describing them in various ways. So when I got to Wall Street, people say, well, we have to get rid of faxes on Wall Street. People are sending faxes for trades to each other, causing all kinds of operational errors. Well, the fax machine went away with the dodo since then, right? But nevertheless, still, it's scanned, electronically scanned documents. Still, so in other words, the fax machine went away. But the problem of having data as documents in natural language form survived the extinction of the fax machine. And with AI, I think for the first time, we have real opportunity of being able to go through all of these documents, convert them into data using a rigorous auditable format where every single step that was taken in comprehension of the document and getting into a database can be then reviewed, audited, right? So if there's an operational error, that occurred during the processing, you can go back and see exactly what happened and how to correct it. So I think the compliance aspect of that is very solid. And this can unlock absolutely tremendous potential. For example, a bank right now is not able to really mine for data the past transactions or analyze them in an efficient way. So our overreaching goal there, so we're just starting from trade entry for what-if analysis, which is something that's very important because it has to be done from the natural way, from the message in a chat or word or email of the trader asking to check the risk of the trade. But we're planning to expand it, go to other types of documents that are in natural language format, but really should be captured as data. And there is absolutely tremendous potential for the application of AI in this direction.
Could you summarize your recent presentation on what if trade entry using LLMs? What kind of feedback or reception did it receive from the quantitative finance community?
Well, I think there are actually two different themes on that, right? So one that has to do with what we're doing, and that one is how we're doing it. So let me start with how. So it's very important for the bank's operations to ensure that we know how accurate it is. We can ensure that it's very highly accurate. And it's not something that, like in a chat application, so it misfires, let's say 10% of the time. That's fine if you're asking it to draft an email, right? You can correct the email before sending it because you always review it, right? But of course, if you're asking it, for example, to recognize a trade from a chat message and check with the risk of the trade, it has to be very highly reliable. And so building reliable workflows is something that we've been focusing on, and when we are able to build reliable workflows in general, then we can apply them to things like trade entry as well as all the other applications. And what we found is that in order to build reliable workflow for the LLM, you have to treat LLMs as humans, right? And it may sound bizarre, but that's exactly what our finding was. We found, and this is something actually what's interesting is that it's not really widely recognized. And I tried in both my presentation in a workshop that we had yesterday, I tried to emphasize how important it is to treat LLMs as humans. And let me give you an example. So sometimes the application is that you have to, let's say, get a schedule, amortization schedule, for example, for a trade from natural language format. And LLMs very often misfire. They add a line, they change the number a little bit, and people get frustrated because they think it's a computer program that malfunctions. But actually, LLM is a different type of computer program. Its ability to process data is more similar to humans' ability, as opposed to a database where you can write all of your human knowledge to a disk, get it back without a single error. If you ask a human to summarize, let's say, a 300-page book, they're able to do it very well, decades after reading it, right? The general meaning of the book. But if you ask someone to read, let's say, half a page of text and then recite it back word for word, including punctuation, without error, especially if it's full of numbers that don't have any particular pattern to them, a human would not be able to do it. So when you try to ask LLM to do it, it's not surprising it fails. In fact, that's because the way it processes the data, which converts it into meaning, and then when it recites it back, it converts it back into text. Neuroscientists think that that's exactly how the way human brain works, and it has a limitation. So instead of, for example, how do we then apply it? Instead of asking the model to understand the amortization schedule and spit it back to us as data, which is similar to asking a human to read the half a page of text, set it aside, right, and then rekey it. Instead, we're simply asking, please mark where it is in the document, and then we use normal Python code without AI to extract it. Because once we know where it is, it's very easy for us to parse it, right? So the key is to recognize where it is within the document and what it is. So we've been able to use techniques like that, where when we're building a workflow with LLMs, we ask, well, would a human be able to do it, right? Would a human, let's say a junior colleague, have enough context or enough background, or do we need to explain something? And once we started approaching it from this angle, we found that the reliability went from 80-70%, 70-80% to 90%, 95, 99% plus, right? So that was an absolutely key thing. Now, once we know how to make it reliable, we can now put it to use in our application, which is trade entry for what-if analysis. First of all, what is it? In a bank, before you can execute the trade, you need to determine its risk and its impact on the portfolio. And normally what happens is that traders have a chat. So traders type in a chat what the trades that they would like to do. Sometimes it's voice, sometimes it's emails, right? So there's an email chain saying, please calculate the risk of this trade. And they describe the trade in natural language, right? All kinds of trades may be proposed. There's a quant normally, or someone working on a trading desk whose job is to enter this trade into the system and calculate its risk. And that's a very repetitive job. People don't like doing it. It requires expertise, but these experts would rather be doing something else. So it's perfect application for AI. This is going from natural language to data, which is what we've been focusing actually at CompatibL, right? So it's a use of generative AI, but not to generate documents, but rather to understand documents and generate data. And this particular application, for what-if analysis, there is 15-minute window while the client is waiting. We can do it, right? If it takes longer, or if someone makes a mistake and trying to correct the mistake, they run out of time. So there's time pressure. So we're trying to make it very reliable, so a human can doesn't have to do it from scratch, but they can review and validate, right? Which is a lot faster. Also, something that I think is more pleasurable, as opposed to sitting, entering the data, right? You review. You sign off, right? It goes. So what we found is that in order to if you ask an LLM, even with the proper explanation of details, to do everything at once, then there is a ceiling to the accuracy. It's like, it gets to 90%, you cannot proceed, you cannot advance further in improving it to 99+%, which is a goal. But what we found is that if you do it in tiny steps, right, in bite-sized pieces, right? So you're feeding a baby, right? You have to be like tiny pieces, right? So the baby doesn't choke, right? So in other words, we don't ask like, what's the trade, right? We say, first of all, what kind of trade it is, right? Sometimes even if it's a specific desk, what kind of trade? Sometimes you have to say what asset class, right? If this is not in the context of a particular desk, right? What kind of asset class? What kind of a trade, right? And then step by step, okay, so it has a fixed leg. Yes, okay, extract the fixed leg. Let's talk about the fixed leg only, right? Forget the floating leg. What is the fixed rate? Right? So by doing it step by step, and at each step providing this context, we're then able to design it the way that humans will succeed, who don't have 10 decades of experience on a trading desk, right? So LLM is sort of like a human who is very smart, right? And I think that this model is really getting smarter, right? But they didn't work for 10 years on a trading desk. So we have to provide all of this knowledge to the model, which you can only do step by step. You cannot give it the whole 500-page book about what all trades could be. So once you get it to smaller pieces, you can then provide information about this particular thing that you're asking, very targeted. Also, we're doing something called corrective few-shot sampling, where say, and previously you made these mistakes and something similar, and here's how you correct it. And that's how you get to this 99+% accuracy in trade entry.
Training the large language models in the same way you would a human.
Exactly. That's right. Exactly. The same way that a senior trader would help a junior colleague. That's exactly the type. In fact, we tell people, if you design your prompt, don't think about this thing being a language model. Think that you're explaining a junior colleague, right? And then the model will understand. Right?
With the ongoing evolution of large language models and their applications, where do you see the biggest opportunities for expanding CompatibL's AI capabilities in financial risk management, and what future trends or technologies are you most excited to integrate?
Right. Well, I think what I will answer. Of course, it's AI, but we're applying it to our traditional business. So, CompatibL has a successful trading and risk software business led by Sergey Niborsky. It has been our bread and butter since 2003. This year we're focusing on integrating all of this AI research that we've been conducting into the system. So the idea, for example, is to, we do what-if analysis, right? So our software accepts what-if analysis using natural language from voice or from email, and then does the whole risk calculation. So we're using our AI research, we're providing open source libraries that incorporate our AI research for free for the use of the community, but we're also incorporating it in our own software.
And what were the key challenges Compatible encountered in adapting large language models for automation of trade entry for what-if analysis? And how did your team address those challenges?
Yeah, so one of the most interesting aspects of this was that only when we put the system into production and we started to work with clients, we realized that some of the techniques we're using cannot get past the AI safety committee in the bank. And we have to go back to a drawing board and redo them such that it's much easier to put the system in production, work in a bank. And here's what I mean. So in a bank, there is a safety committee. Almost every bank has it in some form. Sometimes it's a model risk committee that does it. Sometimes it's a dedicated AI safety committee that whose task is to validate all of the AI that goes in the bank. And rightly so, because of course, unlike some other software applications, AI gives answers, right? So they have to check for things like bias, accuracy. So there are all kinds of checks that have to take place. And these checks have to take place in each new version of the model. And last year, a year ago, our research was focusing a lot on things like fine-tuning, logic warping, and other techniques that change the model. Once we started working with clients, we realized that this technique creates actually a practically insurmountable barrier to adoption in the bank, because if you fine-tune, you change the model, then it's treated as a new model, and again, rightly so, because a fine-tuned model is really giving you different answers than the original model. So then the AI safety committee has to review the model. It takes a long time. Then if it had to be done once, it's fine. But if any software has to be upgraded, right? So we get feedback, we get user reports. So user asked to recognize new traits. Every time we update the software, we found that if we have to wait 3 months for the safety committee to review it, or 6 months, it does take a long time. Then it would really, put brakes on how fast changes can be adopted. It would create this extra barrier that software doesn't involve AI, does not have. So what we found is that we had to go back and build a solution around the standard what's called foundation model. So in other words, the model, let's say it's a Llama from Meta, with GPT-4 from, you can run on Azure, normally banks run it on Azure, from OpenAI, as well as there are excellent models. For example, Claude from Anthropic is an excellent model, which recently were approved in the EU, so now EU can use it as well. So these models are foundation models. They have to approve one and for all. You don't have to reapprove them until the foundation model vendor provides a new version. It happens on a schedule. So these models can be considered approved. And we found that some of the techniques that we're applying using fine-tuning, which is kind of the standard technique to do it, like how to endow the model with additional knowledge. Normally, fine-tuning is the typical answer, but in the bank we found we cannot do it, right, without creating these extra barriers to adoption. So we invented something called reverse lookup, where we found that we can take this knowledge and put it next to the model, right? So in other words, it's not inside the model has to be approved, but it's more like how the model is applied. And this thing, for example, with corrective few-shot sampling, this is accomplishing in a different way what fine-tuning was designed to do originally, where you have all of this knowledge of what went wrong and how to correct it, and we're dynamically using this reverse lookup database, we're looking for this knowledge, and when the model is about to answer the question, say, hey, here are some examples that can help. Right, and here, more importantly, some examples where you previously gave the wrong answer and you were corrected, and here's how. And we found that we can actually get not even the same, but better results than fine-tuning, because we're even more specifically targeting it, while also being able to roll out, when we make a change, we can roll out very rapidly without having to go through the approval process again. And this is actually probably the most important research accomplishment that we made in AI in general, as opposed to a specific application. We're writing a paper about it, actually. In fact, we were going to put it on around pretty soon. So this is probably the most important aspect of our research, that I think has a broader applicability in banking, not just for trade entry, but also generally for how people can use these models and how people can most efficiently put new AI solutions into production without overloading the safety committee with continuous reviews of all these fine-tuned models.
We look forward to the paper. Alexander Sokol, thank you very much for your time.
Thank you for having me.